You know how you clear a clogged drain at home, right? You usually pour some harsh chemicals down it or maybe use a metal snake.
Yeah, but a standard snake really isn't going to reach if that drain is, 7,000 meters underground and choked with solid rock.
Exactly. Welcome to today's deep dive. We are jumping right into a fascinating shift in non-chemical enhanced oil recovery.
It is a massive pivot for the industry, honestly.
Yeah, we are exploring technology from Oildynamics. Based on their extensive applications over in Kazakhstan, they are showing us how to replace massive metal rigs with these ultra-slim tools.
Right, because historically, you'd have to rely on those heavy metal drilling rigs or toxic acids or even literal explosives.
Which sounds incredibly intense.
Hmm.
So our mission today is figuring out how this dynamics shockwave system, or DSWS, actually clears blockages without all those
Well,
chemicals.
the core of it is an electrohydraulic pulse. Think of it as a localized lightning strike underground.
Wait, underwater lightning.
Basically, yeah, they lower this incredibly thin tool. I mean, just 38 millimeters wide down on a standard logging cable.
That is tiny, like an inch and a half.
Exactly. So it stores up electrical energy and then releases up to 300 megawatts of peak power in literally a fraction of a second.
Oh, wow. 300 megawatts, so that just instantly boils the fluid around it.
Right. That violent boiling creates a 50 megapascal shock wave that blasts outward at over 2,000 meters per second.
Okay, let me stop you right there, though, because if I drop a bomb that creates a 50 megapascal shock wave inside a metal pipe, that pipe is going to burst.
You would definitely think so, yeah.
So how does this violent force not just completely obliterate the well's casing?
It comes down to material properties,
Hmm.
specifically elasticity versus brittleness.
Okay, tracking so far.
The metal casing around the well is ductile. It can actually absorb and flex with that shock wave.
Oh,
But the stubborn scale, the salts, the rock, those are highly brittle. So the wave is tuned to shatter the brittle stuff while the elastic metal just takes the punch.
It shatters the glass, but leaves the plastic cup intact, so to speak.
That is a perfect analogy.
Now, the sources also mention it creates worm channels and uses acoustic polyharmony vibrations. What are those doing exactly?
So after that initial shock wave shatters the heavy debris, the system keeps emitting these complex, resonant sound waves.
Like a prolonged vibration.
Yeah. Think of tapping the side of a sieve so powdered sugar falls through. These acoustic waves shake loose the microscopic particles.
Clearing out those tiny pathways to the wellbore.
Exactly. The worm channels.
That is wild. You are clearing blockages with sound and pressure, and what really stands out is you don't need a giant footprint to do it.
Right. It's a rigless through tubing approach. The
Hmm.
tool is so slim it just slides right through the existing production tubing.
So you literally replace the need for those massive metal rigs and turn a process that takes weeks into something that takes minutes.
Exactly. And you do it fast while avoiding heavy kill fluids entirely.
And for you listening, kill fluids are dense liquids poured into a well to suppress pressure, but they can actually damage the flow.
Yeah. Avoiding them protects the well. Plus, saving on rig mobilization cuts OPEX significantly.
But I have to play devil's advocate here. It sounds almost too easy. You just drop a wire line 7,000 meters into the pitch black and zap it.
Well, no, it's a very precise five-step plan. Questionnaire, forecasting, mobilization, stimulation, and evaluation.
Okay, but how do they know they are shocking the right spot?
It is highly surgical. They use integrated gamma ray and casing collar locator sensors,
Which are what exactly?
essentially magnetic sensors. They detect the thick metal joints where pipe sections connect.
Oh, so they map it out.
Right. The surface operators know exactly down to the centimeter where the tool is, so they only fire at the specific blocked intervals.
So no blind blasting. Bringing this all together for you, this deep dive highlights a clean mechanical approach, getting wells back online fast.
Absolutely. It's a huge step forward for the industry.
Replacing toxic chemicals and heavy metal rigs with precise underwater lightning. It really makes you wonder, if we can do this 7,000 meters down, what other industrial blockages could this revolutionize next?
Oh, for sure.
Could we see this clearing deep sea infrastructure or supercharging geothermal energy wells? Definitely something to think about next time you're unclogging a drain.